Yes guys, welcome back to Pure Math School. Today we are going to continue with our introductory work. We are now on the 7th part of the introductory work. That's today we are looking at solutions of triangles. Under this we are going to look at about three things. We're going to look at the cosine rule. Cosine rule, which is in this form: a squared equals to b squared plus c squared minus 2bc 2bc cos a. The sine rule, which is given by a out of sine a equals to b out of sine b equals to c out of sine c. And we look at area of triangles. So today we're going to start with our first one, that's the cosine rule. Cosine rule. So for the case of the cosine rule, we are just going to derive that. Derive the cosine rule, which is a squared given by b squared plus c squared minus 2bc cos a. So let's start straight away as we continue. You'll find that let's consider this triangle. And we actually have two cases that we can derive this in two cases. Let's take case one. We have when we know the height of the triangle. We have the triangle of the the height of the triangle, which comes from the bisecting dropping a perpendicular on the base of the triangle, or one side of the triangle. And another case we will be looking at it when we just create, we actually can't drop a perpendicular, we can just maybe extend to create a perpendicular so that we can get the height. So this is the triangle we are going to consider. Use a ruler because I need a straight line today. And let's assume that our perpendicular is dropping on this side. Okay. And is let's have that let's name this triangle to be A, B, C, and we give maybe an angle at this side, a point A, a vertex A. We let that angle be angle A, and we let here be side B, this one let it be side A, and here we let it be side C, which is that whole of that length. Okay, and we do have this. Let us get this length separately. Let us give this one to be x, that length, so that now this one remains c minus that x. To get this one, that's c minus x. Okay, and we also name our height to be h. So consider the above triangle, that is triangle A, B, C. Whenever you see this side, I'll just be using it to represent a triangle. So we're going to basically use a Pythagoras theory. Let's start by considering this triangle here. from triangle, let me say, let us name here to be n here, where that normal is. We have CNB, triangle CNB. Let's consider that. From Pythagoras theory, we are going to have that no hypotenuse squared is given by side squared plus the height squared. This side squared, the height squared plus the base squared. Now we have our a squared given by that squared plus c minus x squared. Okay, let's call that equation 1. And now from triangle, this CNA, our b squared is going to be given by h squared plus x squared, h squared plus x squared. Let's name that to be our equation 2. Okay, now let's go into we have here, let's try to now we remember cosine rule. The cosine rule is of this form: a squared given by b squared plus c squared minus 2bc cos a. If you realize in this cosine rule that we are deriving, we don't have, the height is not seen there. It's actually there, but we can actually replace it by something. We don't have h there, even this x is not there, but I think we can first start by eliminating the height squared, which will be actually equation 1 minus equation 2 to remove that. Let's say to eliminate h squared, it's equation 1 minus equation 2, so that here we have a minus b equals to h squared minus b squared equals to h squared minus h squared plus that minus that. But you see that our h squared will cancel if you subtract this equation from that equation, so that we are going to remain with a squared given by, a squared minus b squared being given by h squared minus h squared will of course cancel, then remains c minus x squared minus x squared as well. Okay, remain this minus this will cancel, and that will be this other side, so that we have a squared minus b squared will be given by, if we expand this, we are going to have c squared minus 2cx plus x squared. If you remember expansion of under basic algebraic manipulation, we looked at expansion. This triangular this quadratic identities, so that we remember that a minus b squared is given by a squared minus 2ab plus b squared. That's what I've applied here. Or you can expand normally by multiplying two separate brackets like that, then you let each term here to multiply that bracket. Now we continue to say a squared minus b squared is given by that c, we have here x squared remaining, c squared minus, now that one is going away because we open this bracket. Now that x is removing the x that came from that bracket, so remain only 2cx. Actually we have a squared, let's take b the other side to be b squared plus c squared minus 2cx. Okay, now if you look at our previous equation, the one we are trying to derive, we don't have any x there. So what does it mean? We can look for a way of eliminating that x, this x. And now if we go back to our triangle here, how do we get that x? Are you seeing that our x is here, which is the base, the adjacent side of this triangle? We have the hypotenuse there. You see that if we want to consider, if we try to get sine of this angle, we will end up with h. But since we are looking at, we have cos there, we can try to get cos a. That means it can, perhaps can bring us there where we don't have x in that, in our, that can help us remove this x. We need to get that cos a. So if we get our cos a, is going to be given by, cos a is going to be given by, you remember our SOHCAHTOA, in my previous video about trigonometry, introduction of trigonometrical ratios of acute and obtuse angles, I gave this, which is an easy way of memorizing that sine is opposite out of hypotenuse, cos is adjacent out of hypotenuse, and tan is opposite out of adjacent. So we see that cos is adjacent out of hypotenuse, which are adjacent. This angle is adjacent to the 90 degrees or the bisector. So that we have the adjacent becomes x, and our hypotenuse is b. What does it mean? Our x is going to be b cos a, if you multiply it throughout by b to remove that b from there. So we can bring that condition here, but cos a is given by x out of b. Okay, that implies our x actually is given by b cos a. Okay, substituting for x in a squared equals to b squared plus c squared minus 2cx. Okay, that means if we put this x here, we're going to remain with a squared given by b squared plus c squared minus 2c. Now our x is b cos a here. Okay, our x is b cos a, so that we have a squared equals to b squared plus c squared minus 2bc cos a, which is our cosine rule. That's what we call the cosine rule. That is the cosine rule. Now I need to explain to you, to interpret for you that from the cosine rule, or the formula that we have just derived. In our cosine rule, let me write it this side so that you can see clearly. You have a squared given by b squared plus c squared minus 2bc cos a. Now our cosine rule is in this format, and you need to know how how these letters appear and which one do you consider, so that you can actually know, so you don't misinterchange letters in wrong positions. You need to know how, or if you're given a triangle, you know which side it's supposed to fit where in this formula. So you observe this triangle. This is actually for the whole triangle ABC, for the whole of this triangle. Realize that given this side, that also given that side, and we have an angle A here at vertex A. So if you see clearly, this side, which is b squared plus c squared minus 2bc cos A, is actually the side where the angle we are using, this BC is the one which is side B, and side C are the ones creating that angle. So the side that does not create the angle, the square of it is given by the square of the side, the sum of the square of the sides that actually form that angle, minus 2 times the product of those same sides that form that angle, then times the cos of that angle. How do you know that? For example, if I give here for let me say 50 degrees, okay, I have here sine, I have here c, I have here 4, then here I have, let me say I have here x. Okay, how would you express your cosine rule here? You realize that we first need to determine the sides which form the angle, this side and that side. So that means those are the sides going to be this side. It's going to be the 4 squared plus c squared minus 2 times 4 times c, then cos of that angle 50 degrees. So the side that is not sharing the angle, that's not contributing to inclining with anything to give that angle, it's actually going to be on this side. That's how you write your cosine rule for this triangle. So you need to notice that the sides that form that angle are the ones this side. There's sum of their squares minus the twice times the product of their squares and the cos of that angle. Hope I'm clear there. So I think we can now continue. So that's basically the cosine rule. Let me give an example. This side 40 degrees, 3, 2, and here C. Okay, the cosine or rule of it will be C squared equals to 2 squared plus 3 squared minus 2 times 2 times 3, 2 times 2 times 3, then cos of 40 degrees. Okay, need to get that clearly, how to interpret a triangle which has been given to you already, so that you don't just mess up. Let us now look at the second case. Case 2. Now sometimes we might have a triangle of this format. That, and let me say, I may draw this to be somewhere here. Like that, whereby this is not 90, this is just some angle A. That means you don't actually have your height. This at some angle, this was some other angle less than 45, less than 90, and which is that one also we can maybe 45 or not. Now here we can expand this and we create our height clearly. Okay, we expand that. We're just extending to create our height clearly. Okay, then we also have here our side A, B, then C here. That's a triangle with sides A, B, C. But now we don't have we can create this to be our height, and maybe we also give this one to be of length. Let's create here to be, that was point A, B, and C. Then at the 90 degree point here, we put that normal. That's N. So now we are still going to consider we can consider this triangle and that triangle also. That's what we are going to do. We are going to consider BC N. We can consider BC N. Then we also consider we're going to consider BC. That is this one. Then we also consider that, because we always need this height to help us. We consider this one, then we consider that one also. Let's consider triangle BCN. So this BCN, we see that our hypotenuse squared, so it will be given by the sum of this squared plus and the height squared. So we have A squared, still from Pythagoras theory. Let me make that clear, because in math you need to clearly specify the rule you've used or the theorem you've used, so that someone do not question where you're bringing something from. So from Pythagoras theorem, we see that our hypotenuse squared for this BCN, we're going to have hypotenuse squared, which is A squared, is going to be given by this side, which is C plus X. The whole of that length is C plus X. This C plus X, the whole of that. Okay, squared, then plus the height squared. let's call that equation 1. Then from triangle ACN, still from Pythagoras theory, we're going to realize that our hypotenuse, which is b squared, is going to be given by x squared plus h squared. Call that our equation 2. Now we eliminate height again. Eliminating h squared, we're going to have equation 1 minus equation 2, so that we can subtract that and it goes away, so that we have here a squared minus b squared, c plus x squared minus x squared, then h squared minus h squared, which will just cancel. So we have here a squared minus b squared equals to c plus x squared minus x squared, then h squared will just die. This one will just cancel if you subtract this from that. So a squared minus this then equals to this minus that. This one will just plus that minus that, which will go to 0. So that here we have a squared minus b squared is given by c squared plus 2cx minus plus x squared, that's expanding that, then minus x squared. So that we have x squared minus b squared is going to be given by c squared plus 2cx, but this one will go away since x squared minus x squared will go to 0. So that we have here a squared equals to b squared plus c squared plus 2cx. Okay, but what's our x? If you come back here, we need to eliminate that x, because in our cosine rule we don't have that x. Okay, so now we see that from here our x can be, we have here b, we don't bring h again, so we use something, a trig ratio that involves hypotenuse and the adjacent. But now if you consider this angle, we can only use this triangle BCN to get that. So you know that that angle is 180, but now we have already a subtracted, so we have here 180 minus a as that angle. This angle here is 180 minus a, so we can considering triangle ACN, that is, it's like this. There's 90 there, which is at NC there, and A here, and this angle we have A this side, okay, but here this angle here is 180 minus A, because you know a straight line is 180 degrees, like that, 180 degrees. Now if something cuts it like that and this side is A, that means here is 180 minus A. Okay, and you remember in our previous video we looked at trig ratios of obtuse angles. 180 minus some angle is actually an obtuse. You know, obtuse are angles between 90 and 180 degrees. So if you have 180 minus some angle, which is, it was actually 180 and you've subtracted some angle, that means that angle remains obtuse. The whole of that angle A is obtuse. So that means we are going to see that for us to have this was x, this was b, this was h. So which cos trig ratio involves the adjacent, this adjacent to that, and the hypotenuse? I think it's cos adjacent hypotenuse. So that we have our cos of 180 minus a, this angle, is given by adjacent, which is x out of b. So that our x will become b cos 180 minus a. Okay, now it's going to take us back to our previous video. If you didn't watch, then maybe you'll have to go back and check trig ratios of obtuse angles. We're going to have, let's first draw our quadrants. Our quadrants here. We have here first quadrant, second quadrant, third quadrant, fourth quadrant. So that you know that A was an angle measuring into 180 degrees. It was already entering here. It was beyond 90 degrees. This beyond 90 degrees. It goes up to that point. That was A. According to if you interpret this triangle of ours, this angle was already beyond 90. 90 is somewhere here. So it's beyond 90. That means it has entered into the second quadrant, which is into the obtuse section. I told you that this one is acute angle, between 0 and 90. Between 90 and 80 is obtuse. Between 180 and 360 is now reflex. So now we see that in this quadrant, we looked at how to get cos of that. So that let's look for cos of A. Our cos of this angle will actually be, you know that this is 180 minus that. So it's going to be, cos of A is going to be, remember we are about our obtuse angles. Trig ratio of an obtuse angle is actually that same trig ratio of the supplementary angle, which supplementary angles are angles which add up to 180 degrees. So it's a trig ratio of the supplement of that angle. Cos of an obtuse angle is going to be now the cos, same trig ratio, which is still cos of the supplementary angle, which is 180 degrees. Cos of the supplementary angle, which is now 180 minus A. Supplementary angles add up to 180. So now the supplement of A is going to be 180 minus A. Or it's going to be that 180 minus that angle. But with, remember that now about our conclusion about cos of obtuse angle is going to be same as cos of the supplement of the angle, but with a correct sign. And remember we say that here all the trig ratios, sine, cos, and tan are positive. Here we have only sine positive. Here we have only tan positive. And here we have only cos positive. In our previous video, you need to check if you didn't watch our previous video. So now we know that here only sine is positive. That means tan and cos are actually negative. So we are going to attach negative there with the correct sign. That's how. So that means our cos 180 minus A is going to be negative cos A. If you divide throughout by negative to get positive, so that we substitute for that. So that implies our x is going to be negative B cos A. If you didn't understand if you don't understand that, I think our previous video might help about trig ratios of obtuse angles. Always help better. So now let's substitute for x back in that equation. Substituting for x in a squared plus a squared equals to b squared plus c squared plus 2cx. Okay, that means we're going to have, implies that we're going to have a squared equals to b squared plus c squared, then plus 2c. Our x is what? Negative b cos A. So that we have finally, therefore, a squared equals to b squared plus c squared. That minus will now come here, 2bc cos A, if you open that bracket, which is still our cosine rule. I already explained the cosine rule. If you know a triangle, you need to know how to interpret. Now I think we can look at some few examples to cover the cosine rule. We are now going to be faster because now we have got the whole concept of cosine rule, how it's applied. Let's check on some examples. Okay, the first one, find the length of the side BC in each of the following. Find length of BC. Okay, now let me consider that. I'm going to consider both cases, the first case and the second case. So let me have something like that for the first question. Okay, then here I have 32 degrees, then here I have 12 centimeters, 8 centimeters. Then B, let the question be like this. That'd be the best. Then that is a bit more than 100, more than 90 degrees. So something like that for our second case. Let us make there to be 140 degrees. And then here A, B, C, A, B, C. We are finding that length. Then let's put here also same. Okay. Oh, so let's let's get the solution now for these two. Those are the two cases we looked at. So we just look at an example. Let's start with A. Now, observing that, realize that we have sides sharing. Remember, I told you sides sharing are the ones on the other side of the equal sign. So that means the one which is not sharing the angle is going to be this side, and it's squared. So the sides sharing will be this side. They're going to be the addition of the square. That's 12 squared plus 8 squared minus 2, and their products 12 times 8. Then cos of the angle they are forming 32 degrees. Okay, but you have to state from cosine rule. Okay, so from cosine rule we are going to have BC squared equals to 12 squared plus 8 squared minus 2 in times 12 times 8 cos 32 degrees. I'm still repeating, the sides that are forming the angle are the ones on this side of the equal sign. There are some, and minus twice product of the sides of their value of the sides times cos of the angle they are forming. Then the other one which is not forming any angle is the one on this side. So that now we have BC squared is going to be given by we are going to have 12 squared is going to be 144, 8 squared is 64, minus 2 times this is times 12 is 4, is it 24? Then 24 times 8, I think it's 192 cos of 32 degrees. Okay, BC squared will be given by this plus that will be 208 minus, let's see, cos of 32. Cos Trig, when you were expressing causes of angles in or trig ratios of angles in from a calculator, you need to at least consider 4 dps. Now let's see, cos of 32, we have cos here, you see cos is here, so you press cos of the angle 32. That's how you press it. Then press your equal sign here, decimal places, I mean dp. So now so cos of 32 is going to be given by 0.8480 to 4 decimal places, because realize here our next value is 4, which is less than 5. So even if you round to 4 dps, it's going to remain 80. So now we are going to have that times that. So let's multiply 192 times cos of 32. So let's first clear. We have 192 times cos of 32, which is at 162.82. Okay, it's better to do like 162.82. so it's like that. That means we can use that to 2 dps or to 1 dp. Here we have, so we have 208 minus answer 208 minus our answer. What will we have? 45.17. Here was 162.8. So here BC is actually going to be, this is same as 45.17. okay, to 2 dps decimal places. Let's get root of that to get BC. Now BC squared is that. Let's get root of that, which is 6.7. Let's put to 2 decimal places, which is going to be 6.72 centimeters in centimeters to 2 decimal places. That's how we can handle that. So that's our solution for A part of it. Let us go to B. B has that 140 as the angle, and the sides are still 12. We have B still from cosine rule. we have something like that. That's how I think triangle is like 140 here, 12 centimeters, here 8 centimeters. Okay, here is our BC. So from cosine rule, sides forming the triangle are on the other side, minus 2 times the values, then cos of the angle they are forming. Then this side we have the side which is not forming the angle. Okay, that's how I can interpret. So that we have BC squared is going to be given by this still 144, this is still 64, minus 2 times that's still 192, then cos of 144. Let's try to check that from the calculator. Cos is here of 140 equals to negative 0.7660 to 4 dp. It's always good to put cos of trig ratios of angles in 4 decimal places. Negative 0.7660. Okay, so that when you multiply that, we're going to have here BC squared will be given by this one will be 208 still, then plus, because this negative will multiply that and becomes a plus, 192 times that times 192. We already have it there, we just add on. So it's going to be 147. Remember the negative we didn't put in the first one, so it's going to be a positive. We already consider that. So it's 147 to 1 dp. Let's put 147.1. now we add that 208 plus 147.1 will give us 355.1, which is equal to 355.1. Get root of that to get BC, since BC was squared here. Root of that, root of our answer will be 18.8. Let's put it to 1 dp. 18.8 centimeters in 1 decimal place to 1 decimal place. That's how we can handle that. So look at the second example. Number 2, find the angle theta in the given triangle theta. So let's have the triangle. Just draw here. I don't want to use a ruler now. Theta, that angle 4 centimeters, 5 centimeters, then here 7 centimeters. Okay, now we have a triangle of that form. We need to find this angle. So still, let me first redraw it here so that we don't have to open and go back. Here 7 centimeters, here 4 centimeters, here 5 centimeters, and here was theta. Okay, then we have, let's say, from cosine rule. Okay, remember our cosine rule, we have an cosine first, and angles forming the angle, that sides forming the angle will be that we put them on one side like that, then minus 2 times their values, then cos of the angle they are forming. Then the one which is not forming any, the angle is this side. We square that. So we have 7 squared giving us 16 plus 25 minus for another 20 times 40. Okay, cos theta. Here we have 41. 49 here equals to 41 minus 40 cos theta. Take 41 the other side, subtract on both sides. So if we minus 41 here will remain 8. 49 minus 41 is 8, equals to 41 minus 41 is 0, equals to negative 40 cos theta. Okay, so we divide by that, divide throughout by negative 40 to remove from there, so that we have cos theta. Let's now change cos theta. This will cancel, will actually be negative. By 8 will be 1, by 8 will be 5. Negative 1 out of 5, which is the same as negative 0.2. That's exact, I think. Let's first check before we go ahead. 1 divided by 5, 0.2 is exact. So we have negative 0.2 because of this negative. So now we have cos theta equals to negative 0.2. Now how do we get that theta now? Remember, now with this we are going to now get the inverse of the now. To get that angle, we need to get the inverse cos of that to get that angle theta. And we can, another way, we can also use our mathematical thingy. We can use a mathematical table or of cosines to help us get that. But for now, let's use the calculator. Mathematical tables waste our time for now. But still, it's also easy to use the mathematical table. Now let us see this. When we have a cos of an angle giving you an answer, a number, and you want to get the inverse, you're actually going to first of all get the inverse cos of that, which is going to be, you write that angle and you just take that cos the other side to be, but you get the inverse of it, of that number you want. I'm going to show you how you're going to press it on the calculator. And also remember, this is the same as the arc cos of the number. So you get that angle by getting the arc cos of the number that the Trig ratio of that angle was giving. So now we go here. You see this cosine? Cosine is here. It was cosine of that angle, but now we need to get the inverse. Its inverse is down here, arc cos. Let me first bring the calculator closer. If you see that, cosine, then arc cosine there. So now remember the color of that arc cosine is the color of the shift there. So for us to get that one down, we need to press shift, then that to get that. Okay, let me now take it down and it's follow. It's here and arc is down. It's the same color as that shift. So if you get that arc cosine, you're going to press shift, then cos. I think it brings arc cosine. Then you just press that angle, that number. Let's put a bracket since the negative 0.2. Okay, then you press your equal sign. It's 101. So theta is actually 101.5 degrees to 1 decimal place. Okay, or you can read it on a table of cosine by looking for 0.2. Then you read it off the appropriate angle that it will be you'll look for one which is like this, 78 then degrees. Then you look for another antilog of that. And you read the value, it will still be 101.5. That will be the number the answer you'll get. So for today we are done. Now next video will be covering the sine rule, or perhaps if we have time we will also cover we'll then cover the area of triangles. So thank you for coming. Please watch out for my next video. Like, subscribe, share, and don't forget to comment. Thank you and see you in my next video.